working for me. Oh, it is working, so I'm not leaving.
Now both of them are gone.
Okay. I'll record and then they can watch it later when they don't have as many people on the internet. Okay.
Yeah.
But if you open the quiz back up on Google Classroom, then you can see what I'm talking about. Okay.
Wait, let me go open it.
The first one, okay, so we're going over the quiz that you took. The first question, you needed to determine if y equals 2x minus 1 is a linear equation, and if so, put it in standard form. So just by looking at it, we could say, yes, it is linear. That's the first part. That's a point. And this was worth 3 points. That was 1 point. Standard form is when all your x's and y's are on the left and your constants are on the right. Okay, so I'm going to subtract 2x from both sides. So now I have negative 2x plus y equals negative 1. That was 1 point if you got there. Some of you stopped there, so you lost 1 point because the coefficient in front of your x variable cannot be negative. So we have to divide everything by negative 1. And that means we just change the signs when we do that. So 2x minus y equals 1 would be in standard form. That one was worth 3.
My leading coefficient was y minus 2x equals negative 1.
No, the x goes first, and the x has to be positive.
Oh.
Mrs. Palmer, I accidentally put 1 equals 2x minus y. Would that work also?
So 1 equals 2x minus y should lose 1 point. Trying to find yours. 2x. No, that's good. 1 equals 2x minus y. I'm looking at it now. Yep, that was fine.
Okay, thanks.
Yeah, that's just flip-flopping them. Okay. Number 2, the question was, what is the y-intercept when 3x minus 2y equals negative 6 is graphed? So we don't really need to graph it or anything. They're asking, what is the y-intercept? What is y when x is 0? That's what y-intercept is. When x is 0, what is y? So I'm just going to fill in a 0. And that's 0. Negative 2y equals 6. Divide by negative 2. Y equals 3, which is D. Some of you said negative 3. A, you lost 1 point if you said negative 3. It was worth 2 points. So if you said B or C, you lost 2 points. And if you said A, you lost 1 point. And if you said D, you were good. Okay. Number 3 on the quiz. The distance D in miles that a car travels in T hours at a rate of 58 miles per hour is given by the equation D equals 58T. What is the best estimate of how far a car travels in 7 hours? So if we put a 7 in here for T, about how far would that be? So what's the best estimate? Some of you guys gave me like 8, like you did 58 divided by 7. But think about it. What's the best estimate of how far a car travels? So if you're giving me 8, how far a car travels in 7 hours?
Mrs. Palmer, where's this from?
Matthew, what's your question?
What's this from, Mrs. Palmer?
We're reviewing the quiz that you took. So this is not, we're on number 3 of the quiz. Okay, so this wouldn't be, this wouldn't be 8 miles. You wouldn't travel 8 miles in 7 hours. You're going to put a 7 here and give an estimate. So 60 times 7, maybe 420 miles, 400 miles, because you'd be like, that's a little less, something like this. Something around here is what you should have had. That was worth 2 points. If you gave me anything near 420, 400, you got 2 points. If you told me 8, you lost 2 points. Because that doesn't even make any sense that you went go 8 miles in 2 hours, okay? Number 4, they wanted you to graph this. Okay. How am I supposed to graph it? Because we don't really know all the ways to graph yet, but the one way we know is I need to have at least 2 points. I'm going to use my intercepts. So when x is 0, I'm going to put in, let me write the equation first for number 4. Number 4 was 3x minus y equals 3. Okay, so I need to find 2 points. So when x is 0, y equals -3. A lot of you got y equals 3, but that would say -3 equals 3 if you put just a 3 in here. All right, so y is -3. And then, well, what about when y is 0? What would x be? And I think most of you did get x equals 1. You had a little graph here, and all you have to do is graph your intercepts. X is 1, y is -1, 2, 3, and draw your line. Should have looked like that. All right, that's 1. This is -3 down here. That one was worth 3 points. If you found your x-intercept, that's a point. Your y-intercept correctly, that's a point. And you drew your graph, that's a point. Okay? And the final one, I think you guys all did well on it. Oh, I would love to fit it right on this page. So I'm going to stick it down here. Solve 3x minus 45. I think you guys all got this right. Okay, 3x equals 45. X equals 15. This was worth 2 points. Okay, so you have 12 points at the top. So, any questions about those? Okay. Hi, Karen. We're reviewing the quiz. So this was the first 5 questions on the top. The scores aren't on Rediker yet, but I'll put them on later today.
We're having a problem with the internet for some reason.
Okay. I'm recording this also, Karen. So if you get, if the internet kicks you off, you could watch it later on my YouTube. Okay. I'm recording it just in case. So this is going over the top part of the test. We're going to go to the bottom of the quiz. Find the slope. You guys did awesome with slope. For number 1, 6 minus 8 over -4 minus 5. -2 over -9, 2/9. Okay, that was 2 points. And the slope for the second one, -3 minus 4 over 5 minus 9. -7 over -4, which is +7/4. Number 3 is the hard one. So these were both worth 2. Number 3 is worth, I only made it worth 2 because I was afraid that since it was hard, you guys would lose a lot of points. But we're going to do our slope formula. -4 minus 2 over r minus 3 equals 3/2. All right. I'm going to go this way. -6 over r minus 3 equals 3/2. And this is where we cross multiply. 3r minus 9 equals -12. I'm going to add 9 to both sides. So 3r equals -3. And divide by 3, r equals -1, which was b. That one was worth 2 points also. Sorry, these were worth 3 points. That's right. For the slope, if you had, this was 1 point for the numerator, 1 point for the denominator, and 1 point for the sign. So 3 points for these, 3, 6. This one was worth 2. Number 4, determine if this is linear. Okay, not linear. And you guys were showing me how it wasn't changing the same all the time. Is that all you had to do? Determine whether it is linear? Yeah. Not linear. I think everyone got that one right too. Number 5, in 2004, there were approximately 275 students in the band. So that's like 2004, 275 students. In 2010, there were 305. Find the annual rate of change. Basically, they're asking for slope, right? Find the rate of change. 305. Sorry. So 305 minus 275 over 2010 minus 2004. 30 over 6 equals 5. So the rate of change is 5 students per year. So if you said 5, you got all of the points, which was 2 points. 5 students.
Wait, on number 4,
Uh-huh.
I think I got that one wrong because I said it was linear. But I think I
Yeah,
know
me
why.
Let me see.
Because it had +2 on the left side and then -2 +2, and I thought that'd be fine, but I didn't know
Yeah,
if you.
that's what I did also.
Yeah.
Um,
And then on the front, I messed up one.
it looks like this, the one you guys are talking about.
Yes.
Okay, X and Y.
Then you have 0, -2, -4.
Okay,
And
this was a -1, 1. Okay, so this went up by 2,
down by 2.
2. This went
No.
down by 2, down by 2. So this is 2 over -2, so that's -1.
I said they went. Wait.
-2 over -2, that's a +1. So it's not changing the same. This went up 2, then it went down 2. So it has to keep going in the same direction.
How come your arrows are going down? Mine went up. You change them sometimes.
So, you mean the arrows?
Yeah.
Like if I did this?
Yes.
That would be fine. It would still be going up by 2, down by 2, or it would
On
be
the
going
left
down by
side,
2.
they would all be.
Yep. It would just flip-flop them. It doesn't matter.
Wait, so how did we get them wrong? We
Because-
did.
Look, at this is going in the same direction. Your X's are fine. 0, -2, -4, right? So if we kept going, -6, -8, this goes 1, -1. This should say -3. It went down by 2, then it went up by 2. It's supposed to keep going the same, keep doing the same thing.
Okay.
Okay. Any other questions? That was a good question. Okay. So that was the quiz. And then today we're going to check page 174. You had 4 problems to do for homework on page 174. Write an equation in slope-intercept form with the given slope and then graph it. So let's look at number 1. Nicholas, what did you write for number 1 on page 174?
I'm opening up my book right now,
Okay.
and I got the equation
Yes.
y equals 2x plus 4.
Okay. And then they talked about graphing the equation. So to graph it, we were making an XY chart, I think, and saying, what if X is, did we do it like that? 0 and 1?
Yes.
Yeah.
Okay.
Wait.
So when X is 0, Y is 4. When X is 1, Y is 6. So we just need 2 points. You might have used different points. That's okay.
As long as your line looks almost like that.
Yeah. So that line should look something like that. Yours should look better, though, because you're not on this.
Oh, mine's going down. It's starting.
Think about it, though. The slope is 2, Nathan. So that's a puff positive, right? +2. So your slope should be going up.
Yeah,
If
I
the
don't know.
number in front of your X is negative, that's when it would be going down. Okay? So that's one of the things I look at when I do graph a line. I look, is my slope positive or negative?
Well, wait, what happens when it's just going straight? I was looking at the other one. It's just going straight across.
If it's horizontal,
Yes.
Then that would just be a y equals something.
I said my points were -2, 4 instead of 1, 6.
This one, if you put in a -2, you would get 0 out because you put in a -2, that would give you -4 plus 4. So the point -2, 0. So this doesn't look great. It should kind of come down here more where -2, 0 should be a point. Okay, that should be steeper. Number 2. Dun, dun, Gavin, how did you write your equation? Y equals?
I wrote mine as y equals -5x plus 3.
Yeah. Okay, and then we had to graph it. And this is our y-intercept. So I think we talked about that. We just graphed the y-intercept first. Right? And we'll do an XY chart. So that's the y-intercept. That's the point 0, 3. I'm going to pick the point 1. So if I put a 1 in, that's -5 plus 3. My y would be -2. So I'm going to graph the point 1, -2. And when I look at it, I'm like, oh, good, because I have negative slope and I have a nice negative line. So that makes me happy. I feel like I did something okay when I do that. All right, that was good, Gavin. Number 3, Nathan, what did you write? Did I lose Karen again? I did. Okay. Nathan, number 3.
I said y equals 3/4 x minus 1.
Excellent. 3/4 x minus 1. Ooh, I forgot my x. Okay. Y equals 3/4 x
Karen's back.
minus 1. So I have to, hey, Karen, you're back. Hello. I have to graph this. So I'm going to draw my graph. And the first point I'm going to graph is my -1 on my y-axis. Okay?
Yes.
And now I have to find one more point. So I'm going to pick the point 4 for x.
That's what I said.
Good, because if I pick 4, I'll get rid of my fraction because the 4s will cancel.
Yeah.
So 3/4 times 4 is just 3, and 3 minus 1 is 2. So I'm going to graph the point over 4 up 2.
Oh, I see what I did wrong.
Okay, and this is a positive slope, so that's a positive line. So I feel happy about that one. And number 4, Nathan Miller.
Wait, why'd you?
You okay?
Yeah, I just had to fix it. I got these wrong.
Nathan Miller, what did you write for your equation for number 4?
Y equals -5/7 x minus 2/3.
Good. Minus 2/3. Okay, so writing the equation isn't bad. Like we see those fractions and we're like, we're not scared of fractions. We just don't really like them. But they're okay when we're writing the equation. That's no big deal. Now graphing it, when I have to graph fractions, I'm always unhappy, but I'm not scared, right? We just think, oh, that's going to be kind of a pain. It's okay. All right. So I'm going to pick, I have to plot the point -2/3. So I'm going to go down, not all the way to -1, but like 2/3 of the way down and put a point down here. Okay. That's that point -2/3. So when x is 0, y is -2/3. I'm going to pick, guess I'm going to pick 7 for my x so I can get rid of my fraction. Okay, so when x is 7, if I put a 7 in here, my 7s cancel out, and now I have -5 minus 2/3. So when x is 7, y is -5 and 2/3. So this needs to be bigger, -5 and 2/3. It's going to be like way down here. You guys could probably write it better on your paper. I ran out of space. and draw your line. Try to hit your points. Okay, and this I like because it's a nice negative, and I knew I had negative slope, so that looks good also. Okay. Right, do you guys have any questions? Did you have any problems writing the equations? Were you
No.
okay with writing? Okay, so writing the equation, given the slope and the y-intercept was easy for you. How about the graphing?
I suck at that.
Okay, are you okay at graphing the y-intercept? At least at one point, Nathan?
Yeah, I don't know why, but every time I go to graph X's and Y's together, I just mess it up.
Wait, I have a question. If you're talking about like making the line straight, it's impossible for me. But if you're talking about like getting it close enough, then yeah.
Yeah. Basically, I was thinking about like, were you able to find the points? And you can see it's hard for me to make the line straight on the whiteboard. If I would have used the graph paper background, it would have been a little bit better. If you guys have graph paper as we're graphing these lines, you're going to want to use the graph paper. If you have graph paper and a ruler, it makes it really nice. Okay, so I would suggest when you have to graph for homework, it just makes your life easier to use the graph paper. Like you might think, oh, I'll just freehand it on loose leaf paper. You're really just making it more difficult for yourself. When you have graph paper, you're able to count the spots. And as we learn more about slope and how we can graph lines, it'll be really nice to have graph paper. Okay. We're going to continue with our notes because there's more in this slope intercept section. We just did the first part.
Miss Palmer, Nicholas asked you a question.
Oh, Nicholas, what?
Meg,
Oh, you may go to the restroom. Sure. Okay. So we're going to continue on. If you're following along in your book, we're on page 172. Today is December 10th. And we're graphing linear equations. Okay, so far you could write it in slope-intercept form and graph it. That's what you did last night. You graphed the y-intercept, you found one other point, and you connected them. Okay. When an equation is not written in slope-intercept form, it might be easier to rewrite it before graphing. So we have 3x plus 2y equals 6. Okay, let's do that as our first example. We were able to graph that when you took the quiz just this week by finding the x-intercept and the y-intercept. That's one way. They're saying sometimes it's easier to put it in slope-intercept form first. So we're going to put in slope-intercept form. Which means we want y on the left and everything else on the right, okay? So we're going to subtract 3x from both sides. And we're going to end up with 2y equals negative 3x plus 6. And then we'll divide by 2. Divide everything by 2. And y equals negative 3 halves x plus 3. Okay, I'm going to show you another way to graph where you don't really have to find 2 points, okay? So Nicholas, oh, you're not with me, Nicholas. Nicholas and Nathan Miller are the 2 people I'm missing who haven't seen this before. All right, so I'm going to give them a minute to come back. And I'm going to try to put my graph paper background on to make it better for you. Okay. So we're here. Number 1, put in slope-intercept form. We're going to say number 2, graph y-intercept point. All right, so you guys can do that pretty easily, right? Graph positive 3 on your y-intercept. And use slope for the second point. All right. And my 8th graders, you will remember this from last year. I'm going to look for something I want to show you.
Mm-hmm.
You're not presenting.
Yes, not yet. I'm getting there though. Oh, Nicholas is back and Nathan is back. Perfect. Okay. I'm going to try to move my head out of the way and get to my present mode so you guys can write the notes. So Nicholas, copy down the notes that you missed. Okay, what we're going to be doing is graphing a linear equation by putting it in slope-intercept form first. We're going to graph the y-intercept point, and we're going to use the slope for the second point. We're not going to use the chart and try to find a second point. We're going to use our slope, and I'll show you how. I have a video to show you, and then we're going to talk about it. Can you guys see my screen? Gavin, what does my screen say?
Rise up, run out.
Good. Okay.
Rise up or run out. We mapping graphs to the triple R sound. We talking points and slopes, axes and origins. Y intercept and primes result for them. Rise up, run out. We mapping graphs to the triple R sound. We talking points and slopes, axes and origins. Y intercept and primes result for them. The 4 quadrants start from the top and right, counterclockwise from the positive X and Y. You go around, hit the 2 and then 3, bottom left, negative. Remember that, please. You got a single point on the X, Y grid. There's a single pair of values telling you where it is. This X coordinate goes from side to side. The Y follows the comma to define the points. A straight line between 2 points is a relation. You can represent it with a linear equation. Y equals M times X plus B. If you want to know the variables, listen to me. M is the slope, that's rise over run. It tells you how steep the line is going to become. B is the intercept, that's how you assess the point at which the line goes through the y-axis. Rise up or run out. We mapping graphs to the triple R sound. We talking points and slopes, axes and origins. Y-intercept and primes result for them. Rise up, run out. We mapping graphs to the triple R sound. We talking points and slopes, axes and origins. Y-intercept and primes result for them. Say you got a job and you're earning your pay. You start with $50, then get 9 every day. You wanna know over a year how much you get. Calculating that graph might be your best bet. On the edge, you measure it one day at a time, and your money gets tracked on the vertical line. Now you got some, and you ain't even worked yet. $50, put it up, that's your y-intercept. After the first day, you got 59. Now you got 2 points, you can start drawing a line. The slope of that line, remember, rise over run. If dollars over days, then you got none over ones. Remember B, I think that's where we started at. $50 up on the graph, the y-intercept. And you know y equals mx plus b. Now you got y equals 9x plus 50. Rise up or run out. We mapping graphs to the triple R sound. We talking points and slopes, axes and origins. Y-intercept and primes result for them. Rise up, run out. We mapping graphs to the triple R sound. We talking points and slopes, axes and origins. Y-intercept and primes result for them. Rise up. Rise up.
Okay. Okay. All right. So there went our video. Slope, rise over run. So always think that rise up, run out. Okay. So we're going to be graphing using that idea. First, we put it in slope-intercept form. Okay, so we put this in slope-intercept form, and we can graph pretty easily, actually. Okay, so draw yourself your x, y axis. Okay. All right, so number one, put in slope-intercept form. Check. Number two, graph the y-intercept point. My y-intercept is positive 3. So I go up 1, 2, 3, and I put a point. All right, and you guys told me with your homework last night that part was easy, right? Now, use slope for second point. Rise up, run out. All right, my slope is -3/2. So the only thing you have to think of with the rise up, run out is if your slope is negative, you go down first instead of up. Okay, so your slope is up and out. But if your slope is negative, you're going to go down and out. So my slope is -3/2. So I go down 3 to the right 2. I always go to the right. So I either go up or down, depending on if this is positive or negative. Okay, so I go up or I go down 3 because it's a -3/2. That's how I get my second point. So I didn't have to like substitute anything in. I could just use my slope to find the second point and graph it. And if I draw my graph correctly, I should be able to, every point on the line should be down 3/2, down 3/2. Okay. Down 3/2. But I only need those 2 points to graph it. So let's try another one. I have time, right? Yes. Okay. And I'm going to give my graph paper here because I'm going to be graphing. All right. Let's try example 2. So 3x minus 4y equals 12. All right. Step 1, put in slope-intercept form. All right. So I'm just going to write myself a note there. Put in slope-intercept. So I remember. All right, so that means I want y on the left, everything else on the right. So I'm going to subtract 3x from both sides. So I want to get my y all by itself. Those cancel out, and I have -4y equals -3x plus 12. But y has to be all by itself, so we have to divide by -4 everywhere. Y equals 3/4 x minus 3.
The state like Colorado or Hawaii, something like that. But it's not.
Okay. So we have it in slope-intercept form now. All right, I'm going to make myself a note. Number 2, graph y-intercept point. Okay, so my y-intercept is, what's my y-intercept, Matthew? Maybe it's hard for you to unmute. Let me see if you type something in there.
-3.
Oh, there you go, -3. Yep. Okay, so I'm going to graph my y-intercept, -1, 2, 3.
Is it -3?
Yes, good, -3. Now I'm going to graph my slope point. So use slope for second point. All right, my slope is 3/4. It's positive. Rise up, run out. So rise up 3, out 1, 2, 3, 4. Okay, rise up, run out. Rise up 3/4.
Awesome.
That's a really bad line. Maybe if I use a line thing. Let's try that. Still not good.
Oh, my graph's a dandy. It's beautiful.
By George, I think I've got it. Kind of. Okay. So it should look like that. This is a positive slope. So I feel pretty happy. Puff, puff, positive. And then I can see my slope up 3/4. So that looks good. Okay.
Well, now it's not hard making graphs.
It's not hard anymore? All right, let's
Just
try
do more examples.
example 3. All right. Put in our background. Okay, example 3. And it's going to be the one from your book, negative 2x plus 5y equals 10. All right, we want to put it in slope-intercept form. So we move x to the other side. That gives us 5y equals 2x plus 10. But y has to be all by itself. So we divide by 5 everywhere. Y equals 2/5 x plus 2. Okay, I'm going to draw a graph. Graph my y-intercept. Nathan Snyder, what's my y-intercept? What point am I going to graph on my y-axis?
On your y-axis, you are going to graph 2.
Good.
Positive 2. So 2
Positive 2. And my slope is positive also, positive 2/5.
So go up 2.
Uh-huh.
And then over to the right 2.
Over to the right, how many?
Oh, 5.
5. Up 2 to the right. 1, 2, 3, 4, 5. Rise up, run out. Okay. And that's your graph. I really like graphing this way better also.
Mm-hmm.
All right. I'm going to give you one more before you leave me for you to try. Maybe I'm going to run out. I'll just tell you what your homework is. I think those 3 graphs will be good practice for you. And I'm going to have you guys work on okay, page 174. No. Okay, page 174. Numbers. I'm going to give you 5 to 10, even though we didn't talk about 9 and 10 today. We talked about that before, where if we just had y equals, it's a horizontal line, and x equals would be they don't have an x equals, but that would be a vertical line. But so 9 and 10 are going to be horizontal lines. Okay, so you're going to graph it using this method. Put it in slope-intercept form. So solve for y, graph your y-intercept, and then use slope to find your second point.
Okay.
Okay?
Thank you.
You're welcome.
Bye. Have a good day. See you in finance.
I'll see you in finance.